All right, so today we are going to talk about force diagrams. Now, you've gotten a little preview of them yesterday, so we're going to start by talking about what you looked at with your readings, and then we're going to talk about how we do them, including a couple of vocab words that we're going to need to know along the way. So, our language objective is, I can take focus notes and complete practice problems on force diagrams using a teacher video guide, this thing, and sample problems. Okay, so the first word I want to talk about is net force. So net force should be reviewed from your previous reading or video, whichever you chose to do. But the net force is the sum of forces. So basically what this means is that when we add up the forces, we are going to get some number. And it's usually adding them up in opposite directions. So let me show you an example. If I have 3 newtons of force. Now remember, if you don't have this somewhere, a newton, also labeled capital N, is how we measure force. So if I have 3 newtons of force pulling to the right and 3 newtons of force pulling to the left, and I add these up, I have 3 newtons plus 3 newtons going one way and 3 going the other way. You can think of this kind of like positives and negatives. So this is like a plus 3 over here, and this is kind of like a minus 3 over here. So if I have 3 pulling on one side and 3 pulling on the other, if they end up being equal, then there is a net force of 0. So again, it is kind of like positive 3 plus negative 3. And when you add those together, we get 0 newtons, not on, 0 newtons. And that would say that our object isn't moving. Now, if I were to go ahead and add another set of arrows in here, 2 newtons and let's do 6 newtons. So I have 2 newtons up. I'll keep that as a positive. And then I'll use my minus 6 newtons. Okay. I know that those aren't equal. So if I add them together, I get minus 4 newtons. Really good minus sign, Mrs. Vito, really good minus sign. Those minus 4 newtons, okay, tell me that I am going 4 newtons still, and I am going to be moving down. Okay, because this one is bigger than this one. I'm not moving side to side at all. Those are balanced, those are equal, but I am going to be moving down since my bottom one is bigger. So net force is the sum of the forces acting on an object. So whether that is on the horizontal, the stuff that I've written in red, right here, whether it's acting this way, whether it's acting on the vertical this way, whether it is acting on some crazy diagonal direction, however it's moving, right? It's adding them up, and then you're really looking at the ones that are opposite one another. So let's go ahead and talk about 2 more words, and let's get into some problems. So let's go ahead and talk about balanced forces. When we talk about balanced forces, please add this to your vocabulary section. Balanced forces have a net force of 0, meaning they're not moving. All right, net force of 0, meaning they're not moving. So we have in our examples off to the side, we have a girl sitting in a chair, and the weight or gravity is pulling her down, but the chair is keeping her up, right? The chair is not letting her fall through the center of the earth. Okay. Same thing here with this person. Person here, gravity is pulling them down, but then their feet standing and pushing on the floor is keeping them up, keeping them from falling to the center of the earth. It's kind of silly to think about that because we don't usually think of any forces acting on us other than gravity when we're sitting in a chair or when we're standing. But yeah, that is actually a force that we'll talk about a lot because gravity does play a big role, and then if you're not moving, that means you're still fighting gravity. If you're falling, obviously gravity is going to be the bigger force, but in this case with that not moving, That's showing that gravity's pushing down or pulling down, but the ground is pushing back up. You're pushing the ground, using the ground to push back up. Here's a more common example. I have one little kid pushing a truck to the right and one little kid pushing the truck to the left. The truck stays still. And then we have our skateboarder example. He is pushing with 100 newtons of force forward, but the force of the air resistance is pushing him 100 newtons backwards. So 100 and 100, that would tell me that those are balanced. And then 680 newtons of gravity pulling down and 680 newtons of the skateboarder pushing up. So most of the examples that we're going to use starting out aren't going to be objects like the car or the skateboarder or even the person on the chair. What we're really going to be looking at are boxes. So here's a box. And next to your little vocab word, if you want to draw this box pretty small, it might be helpful. You do not have to. So a balanced force can look two ways. It can look with the same size arrows going in opposite directions. Okay. If there are no numbers, you're going to want to look at the size of the arrows. Or it can look with the sum of the forces being the same. So I just did this example. 3 newtons on one side, 3 newtons on the other. If you're pulling, they're going to cancel each other out. We have 0 newtons. Another thing that could happen is we could have something that has 4 newtons pulling one way, but then 2 newtons pulling twice in the opposite direction. So when I think of this, I tend to think of a tug of war. I have somebody who is really strong, pulling with 4 newtons on one side, and then I have 2 people who are not as strong, each pulling with 2 newtons. So if I were to take these together, 4 newtons, grab a colored pen, 4 newtons, and 2 and 2, 2 and 2 added together gives me 4. So 4 is equal to 4. That would mean, again, we have 0 newtons of force. And those are, again, zeros, not ons. So balanced forces, net force of 0. Okay, let's go ahead and try unbalanced. So unbalanced forces, go ahead and add this to your notes as well in that vocab section. Unbalanced forces is simply the net force is not 0. Okay? Which means the object is moving in some way, shape, or form. So the examples we have here, a person pulling with 50 newtons one way and the other person pulling with 30 newtons, right? These aren't equal. 50 and 30 are not equal. So you could tell me that the person with the bigger newtons, this person over here, is going to win, which means they're pulling in that direction. I also have a bird falling down. Gravity's pulling the bird down with 25 newtons, and the air resistance is pushing back up with 16 newtons. Okay? I know that 25 is bigger than 16, so I know the bird is going to be pulled down. Same thing here, we have one where we add 3 newtons pulling backwards, 4 newtons pulling forwards. 8 is bigger than 3, I know it's going to move to the right. And then 300 newtons of thrust from the rocket with 100 newtons of weight or gravity pulling back down. 300 is bigger than 100, so I know that the rocket is going to move up. So I just talked through a lot of those examples if you want to draw this little box next to your notes as well. An unbalanced net force or an unbalanced force diagram could look like some of these examples we have here. So we could have something like 20 newtons pulling up, but only 10 newtons pushing down. So to find the net force of this one, 20 and 10, I could say that 20 newtons, I know that one's bigger, minus 10 newtons, I know that one's smaller, gives me 10 newtons of force, and then now I need to add a direction. So it might be important to note that you are going to need a direction with your forces. So I know that it's going to go 10 newtons, and then which one is bigger? The up. So 10 newtons of force up. Okay, I'm going to move that over. the side-to-side example, I'll give one of those as well. Okay, if I have 2 newtons of force going this way, and 3 newtons, and 1 newton. Okay. So I would start by adding these together. This would be 4 newtons, and this is 2. So I know my 4 is bigger. 4 minus 2 leaves me with 2 newtons. And then I have to give a direction. It is going to the right. All right, so that's an unbalanced force. Okay, so now we have 3 words in our vocab that we're gonna look at: net force, balanced forces, and unbalanced forces. Let's go ahead and give each one a try with 2 problems. Okay, so here we have some force diagrams. Notice that these force diagrams don't have numbers. So we have to figure it out by looking at the size of the arrows. Now, I drew these arrows. They're pretty general. Okay. Looking at the sides of the arrows, which force or which way the box is going to move. All right, so we don't have any numbers. We can't give you how many newtons it's going to move, but we can tell a direction. So when I look at this first one, I am seeing, okay, these look about equal. So I know it's not moving up or down. I'm just going to stay still. And then I can see here, big arrow, little arrow, that this box is probably going to be moving to the left. That's it. That's all we have to have. Okay. If I look at my bottom box, I see 2 arrows pulling to the left, 2 arrows pulling to the right. They're about the same size. And then I have a big arrow, a little arrow pulling up. So that would probably tell me that this box is going to be pulled down. Again, that's it. If there are no numbers, it's basically telling me which direction it's going to move. Down and up. All right, now let's try one with some numbers. So this yellow box here has 24 newtons of force pulling to the left and 12 newtons of force pulling to the right. So I can go ahead and say 24, I know, is the bigger number, minus 12. That leaves me with 12 newtons. And then I have to give the direction. So it would be 12 newtons to the bigger one. So the bigger would be the left. 12 newtons to the left. Done. Okay. Now, bottom green one, bottom green square, 5 newtons to the left, 7 newtons to the right, 3 newtons down, 3 newtons up. Okay? So I'm seeing 3 down, 3 up. Those cancel each other out. So that part is balanced. And then I see 5 newtons to the left and 7 to the right. I know 7 is bigger than 5. All right, that leaves me with 2 newtons. And then remember, I have to give a direction, 2 newtons to the right. Okay, we just went through 4 problems pretty quickly. Know that things can go in more than one direction. So if I were to have an example like this, where I added another 2 newtons to the top, I would say that this is going 2 newtons to the right and 2 newtons up. So you might need to include more than one on our practice problems as they come up, especially on Thursday. Otherwise, this is it. This is force diagramming at its form that we are going to learn in 8th grade. Once you get the hang of it, it should go pretty quickly. If you are struggling, please let me know. I am going to do a live lesson on Thursday.